a portion of a signal. Okay, fine. This is electronic circuit which is used to clip a portion of signal. Fine. So here already I have prepared some material. Like if I just want to categorize the clippers, simply clippers can be categorized into two parts. Clippers. So there are two parts of the clippers. First one is series clipper and second one is parallel clipper. Okay. Series clipper can further be categorized into two parts like positive, positive and parallel filter can also be categorized into two parts, positive and negative. All the candidates are requested to keep themselves on mute. Okay, so these both can further be categorized as biased and unbiased. Okay, biased, unbiased. Fine. So clippers, you understood what is clipper exactly. This is used to clip particular portion of a wave. Like suppose I'm having a signal. Okay, I'm having a signal. Okay, and if I apply the signal at the input of any wave, and I just want to find any signal at output which does not contain this portion. Okay, so this portion can be removed by using clipper. Fine, there is no this portion. This is called clipped signal. I hope you understood. Any portion like this, anywhere we can clip using clippers. Okay, fine. So here first I would like to explain about positive clippers. Positive clippers means you see here. Okay, before going on that, I would like to explain the operation of clipper. First, one operation I will explain, and other operation you will understand by yourself. Suppose I am having this circuit. Okay, and here if I talk about series clippers, so in the case of series clipper, diode is in the series to input. Okay, in the case of series clippers, and diode is in parallel to input. This is in the case of that parallel clippers. And the meaning of positive and negative, you understand. If we just want to click this positive side of waveform, okay, then it is called positive clipper. Okay, this is output waveform, positive clipper. And if we want to clip the negative portion of wave, this portion, okay, so this is negative clipper. Negative wave, negative side of wave is clipped, and positive side of signal is clipped. Fine, and biased and unbiased, you will understand. First of all, I'm taking this kind of clipper. This is diode, this is resistance, and this is the voltage. Here, this is the terminals at A and B across which we have to collect the output voltage, and this is the terminal VI at which we are applying some input voltage V. So tell me whether this is series clipper or parallel clipper. Yes, because diode is in series to be applied in voltage. Yes, exactly. This is series clipper. So whether we will find whether this is positive clipper or negative clipper. Now we'll decide. Okay. So here, um, first of all, first step, I'm applying positive half cycle. Positive half cycle of the input. For positive half cycle of the input, what happens? Diode D acts as open circuit. And how much will be the voltage, output voltage? Tell me. Deepu does. Okay, open circuited and no current will be flowing through this from input to this load resistance. And second case, during the negative half cycle, what we do, diode behaves as short circuited. Okay, and that will provide you how much is the, if suppose this current is I T, so in that case V naught will be IR equals to VI. Okay, so V naught will be, because VI is in parallel to IR, and this is parallel to V naught. So that's why V naught will be equivalent to VI. Exactly. Is that fine? So I think there is no problem. So we can draw this waveform. So here, if we draw this waveform, the input waveform and output waveform together. Okay, we know T. Here, if this is input waveform, okay, and so what will happen during the positive half cycle? You see, this is the 0 volt here, okay, and during negative half cycle, V naught is exactly equals to VI. So I'll get this waveform. So tell me whether this is positive clipper or negative clipper. So this is this is series positive clipper. Okay, and one more thing, this is unbiased. Now I'll tell you what is the difference between biased and unbiased clipper. Okay, this is the terminal where we are collecting output. This is diode, you understand well, this is resistance, and this is the battery having positive and negative terminal like that, and this is the input voltage, whatever we are applying at the input terminals. Okay, fine. So during positive half cycle, take care of that input, and in that case, this diode diode will be open circuit. Okay, diode will be open circuit, and ultimately the output will be 0. diode is open circuit. Fine. Second one, if we consider the negative half cycle of the input, so in that case, diode will be short circuit for negative half cycle. So we'll do this mechanism like that. This plus V, and if current is flowing like that, IR plus IR, and then IR equals to, it is V naught. IR is exactly equals to V naught. Okay, so we can write it, and here this is for negative half cycle, this is minus, this is plus. So this is plus VI plus V plus IR means V naught equals to 0. So we will say like that, V naught equals to minus Vi minus V. Fine. It means we can say on the negative half cycle, this is called biasing. Biasing voltage, or biasing battery. So this kind of clipper is negative clipper. Okay, so whatever we are getting at the output here, this is Vi and plus addition of some biased voltage. So if we draw the waveform, so we can draw this waveform like this is T, and again this is T, and this is for input voltage, this is for output voltage, and so again you can understand that for the positive half cycle, this diode is acting as open circuit, so no current is at output, and somewhere we'll get this output here. Fine, we'll get this output like that, and so we can say this is series positive clipper with biasing. Fine, I hope you understood the meaning. Okay, let me explain the things in detail now. So simply you understood the meaning of positive clipper and negative clipper. There is no doubt. Positive clipper means positive cycle, positive side of the signal will be clipped, and negative clipper means negative side of the signal will be clipped up. Fine. And here series clippers means diode is in series with the input, and simply you see the operation now you can perform. Okay. And one more thing, here we are considering the ideal diode in all the cases. And biased, this is unbiased series clipper, positive and negative. Okay, in the case if you just want to implement that negative clipper, you just have to revert the direction of this diode, and you will find negative wave clipped. And in the case of clipping, so you understand this concept here. This, if you apply some input voltage here V, so output is somewhere in addition with this, like that. Understood my point? So here on the next slide, if you will go, so this will be some addition. Means here if this is minus V already, so it will be minus Vi minus V. Okay, this portion is added. This portion is added to the waveform just because of this. Fine. And here you can understand this concept if you just want to implement that. If you want to, here you can see this kind of waveform. Fine. But if you want to implement this kind of waveform, so you have to revert the direction of this battery. Okay, if you want to take this portion only. Fine. So V will be deducted. So in that case, if you take V positive, then it will be like that. Fine. And in the case of negative, type of the series clipper, bias series clipper. Just have to change the direction of diode. I hope you will understand the operation of this clipper easily. And parallel clippers. So first we will discuss the operation of this parallel clippers. Then we'll talk about that. Okay, I'm talking about one circuit. So here these are the terminals where you are collecting the output, and this is diode, this is resistor, and this is input. Fine. We were explaining the parallel keeper. So simply we are collecting the output across the diode, and diode is in parallel to the supply. That's why this is parallel keeper. And you can understand during the positive half cycle. For the positive half cycle, you can understand like simply this is positive, this is negative. For positive half cycle, diode is short circuit. And during this short circuit stage, how much will be the output? Tell me.
VI.
VI, sir.
VI.
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 Sir, input voltage is output voltage.
Lens circuit model for
Z.
Zero. It's zero.
for positive half
Zero.
cycle. This is short circuit. Now tell me, Tanvi, Tanya, Tanvi,
So,
speak up.
so
Hmm?
there is no diode. So it's short circuit, so it would be zero.
Understood? So short circuit always provides resistance 0. So here V output equals to I dot R. So R is 0, I into 0. So it will be 0. So output voltage will be 0 during positive half cycle. Okay, during negative half cycle. During negative half cycle, diode is open circuit.
Oh,
Okay, diode is open circuit. So what will be the output voltage?
sir, V naught.
Hmm?
VI. मतलब V
V
V
naught.
output.
Now tell me.
V input. IR plus
Hmm?
Sir, minus V input minus IR.
So less than V input, something less than V input.
What will happen with R?
Plus IR.
minus
So less
minus
than
IR.
V
Plus
input.
IR.
Tell me the value of current in this branch.
Zero. Zero.
Zero.
Sure.
Zero correct, sir.
No.
Yes, sir. Zero.
Zero.
This is open circuit throughout. So no current will be there. So IR effect potential drop across resistance will be 0.
Zero.
Okay. So here we can draw the waveform. Okay. So now if we'll draw the waveform, so now understand this operation. For positive half cycle, this is 0, and for negative half cycle, this is minus whatever voltage you are applying at the input. This VI. Okay, and this is for positive clipper, unbiased positive. This is negative clippers. Only direction of diode is reversed. So you will find negative waveform clipped. And if you apply some biasing, and biasing means the bias voltage is applied with the diode. Okay, and now whatever is the value of V, it will be clipped. For positive clipper, can you perform the operation of this biased clipper? Okay, let me do it. This is diode and this is P plus minus. This is resistance for positive half cycle. For positive half cycle, diode, what will happen with diode? Diode will be short circuited. Okay, for the positive half cycle, diode will be short circuited. So you can apply some minus VI plus IR plus V goes to, tell me the output voltage. Tell me the value of output voltage.
Output voltage equals to V, sir.
V, sir.
Sure,
V.
it will not affect
V,
the
sir.
V. Okay,
V.
the output
VI
voltage will be
minus
V,
IR.
capital V. Output voltage will be capital V because this voltage will be similar as output voltage. For negative half cycle. For negative half cycle, you can understand. For negative half cycle, this is negative. This diode will be open circuit. If diode is open circuit, how much current will be there in this branch?
Zero.
Zero
Zero.
current. Okay, so V output will be equals to VI.
Input. V input.
Okay, fine. So we can draw a waveform.
Excuse me, sir.
Yes.
Sir, if we insert any voltage across upper branch, then there is some VI minus V, na, sir.
Where if we place some voltage here,
Yes, sir. Upper, yes, sir.
so accordingly you can apply KVL KCL. Yes, yes, exactly. Whatever you are saying is correct.
Okay, sir.
Okay, so fine. So this is about the operation of clippers. Now, next operation I would like to perform clampers. What are the clampers? Simply, you see, this is clamping network. So here, this is diode, this is resistance, and this is capacitor. Here we introduce a capacitor, okay, along with diode and resistance. So this circuit will be performed, and this circuit will be called as clamper. R diode C VIT. Okay, we'll just try to understand the operation of this clamper circuit. First, for positive half cycle. For positive half cycle, what will happen? For the positive half cycle, this diode will be short circuited. Okay, and if this diode is short circuited, how much current will be there across this resistance, or how much current there?
Infinity.
Total current
Zero.
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 Zero. Zero, sir.
Yes, there is always a concept. Current follows
Least resistance.
the least resistance path. Okay, if diode is short circuited, so maximum current will be there. Do you know why? If this branch will be providing zero result, then I equals to V upon R. If R is zero, then it is zero, then it will be approximately infinity, mean maximum current. This can be called as maximum current. And what can be the maximum current? Whatever current will be there. This is total current will be passing through this path only and then grounded. Okay, means this current will be zero. No current will be moving to this branch if this is short circuit. Understood my point? So never try to be confused. If you get short circuited anywhere in the network, then the current will definitely follow that path only, and the current in other paths will be zero. Understood my point? So if somebody says that, if somebody is confused, never be confused in that way. Okay, this is very important to understand. Okay, in that case, if this is zero, if this is zero, so capacitor starts charging during positive half of the applied input. Understood? Capacitor will start charging. Fine. Is there any problem? No problem. For negative half cycle. For negative half cycle, what will happen for negative half cycle? You just see what will happen with this diode. For positive half cycle, this diode was short circuited. For negative half cycle, this diode becomes open circuit. Okay, and here, if this diode is open circuited during negative half cycle, and what will happen? Already, if I say this is a sinusoidal input voltage, and if I draw the waveform of the signal, then if I draw the waveform of the signal simultaneously, fine, and here fine, this is the waveform, whatever it's seen for the applied input voltage VIT, and if I consider this is having maximum value capital V, and in the negative side this is having maximum as minus capital V. This is pi, this is 2 pi. Okay, Fine. So what will happen here for negative half cycle? This diode is open circuited, already. Okay, we are considering this negative half of the signal, and for positive half, capacitor started charging. And up to how much value capacitor will collect the charge? This is maximum value of this positive half cycle, capital B. Means capacitor stores the charge that can create the potential of maximum value, capital B. Understood? And here for the negative half cycle, you are saying this diode is open circuited. So this path will be removed out from this whole network. And now this capacitor starts discharging across this resistance. This supply the current to this resistance. And how much voltage can be dissipated across this resistance? This voltage will be maximum voltage, that will be V. Capacitor starts discharging across the resistance R and creates the maximum voltage drop of V across the resistance. I hope you understood. During negative half cycle, this capacitor starts providing some charge. Then can you find out the output voltage? So here you can check what is the value of this output. For this case, you can see the output voltage. You can apply here. This is Can you see? Can you comment on that?
Sir, it will be minus 2 Vi.
Yes, it will be minus 2V. And Vi is having maximum value. This is
Yes, sir.
capital V. Yes. So it will be minus 2V. Okay. So that's why you will draw a waveform here. You are good. You are brilliant. Good. Very good. Okay. So here, if you will draw the waveform, then definitely minus 2V means this will be, if this is rectangular pulse here in place of sinusoidal, then it will be minus 2V. Minus 2V. Okay. If you take sinusoidal pulse, then its magnitude will be double to minus 2V. Fine. I hope you understood whatever I just want to deliver. So here you see this example. This was the input signal having maximum of capital V and time period capital T, and this was applied at the input of the circuit. This is called clamping circuit. And here ultimately at the operation end you will find the 2V of negative side voltage. Okay, so and here you see for this kind of clamping network, whenever you revert this direction of this diode, so this whole signal is shifted upward. Here you just think, if this signal is shifted downward, then you will get this kind of waveform. Do you understand? For shifting this signal network, then you will find this kind of waveform at the output. If you shift the signal downward, then you will find this kind of wave at the output. In a similar manner, if you shift If you apply some biasing voltage here across this diode, in that case, the signal, the level, how much you want to shift, you can decide by yourself depending upon the level of this voltage. How much voltage level you can achieve. Fine. In the similar manner, if you change the direction of diode, if you change the direction of this applied battery, so you can further go in the negative direction as well as like that. I hope you understood the concept of this clamping network as well. Is there any doubt?
So how did it become?